Imagine spending billions of dollars, marshalling your nation's finest engineers, and building one of the fastest military aircraft ever created, all to destroy a single enemy plane. Now imagine that plane never existed, not in the way that mattered anyway. In March 1961, the Soviet Union initiated a classified program to create a super interceptor capable of reaching Mach 3 and climbing to 70,000 feet. Its sole purpose, to hunt and kill the North American XB-70 Valkyrie, America's revolutionary supersonic bomber. The Soviets poured resources into this program, convinced that fleets of Valkyries would soon dominate their skies. But here's the paradox that defined an era. By the time the MiG-25 Foxbat rolled off Soviet production lines, the XB-70 program had been cancelled. Only 2 prototypes ever flew. The threat that justified an entire weapons system had evaporated. Yet the MiG-25 became one of the most feared aircraft of the Cold War, a ghost chasing ghosts across hostile skies, rewritten for missions its designers never imagined. This is the story of how Cold War paranoia, technological ambition, and strategic miscalculation created a legend. This is the story of a weapon built for a war that never came. In the late 1950s, the United States Air Force envisioned the ultimate strategic bomber, an aircraft so fast, so high-flying, that no Soviet defense could touch it. This was the North American XB-70 Valkyrie. The specifications were staggering. Sustained flight at Mach 3, over 2,000 miles per hour, at altitudes exceeding 70,000 feet. At those speeds and heights, the Valkyrie would outrun any interceptor and fly above any surface-to-air missile of the era. The Valkyrie wasn't just fast, it was enormous. With a wingspan of 105 feet and powered by 6 General Electric turbojet engines, this delta-winged colossus represented the pinnacle of American aerospace engineering. Its design featured revolutionary canard surfaces and wingtips that folded downward during supersonic flight to ride its own shockwave, a phenomenon called compression lift. The bomber was intended to deliver nuclear payloads deep into Soviet territory, unreachable and unstoppable. In strategic air command planning rooms, the XB-70 represented invulnerability, the ability to strike Moscow with impunity. But aircraft of this caliber don't come cheap. The estimated cost per unit, $700 million, equivalent to approximately 7.8 billion in today's currency. Each Valkyrie would cost more than a small fleet of conventional bombers. Still, in the mindset of 1950s Cold War America, no price was too high for strategic superiority. Development began in earnest, and the first prototype took shape in North American Aviation's facilities in California. The vision was clear. A fleet of these magnificent machines would ensure American dominance in any nuclear confrontation with the Soviet Union. The Valkyrie embodied a particular moment in military thinking, when bombers still represented the apex of strategic power. Nuclear weapons could only reach their targets aboard aircraft. Ballistic missiles were still experimental, unreliable. The bomber reigned supreme, and the XB-70 would be its ultimate expression. Engineers confronted unprecedented challenges. No aircraft had ever sustained Mach 3 flight for extended periods. The aerodynamic heating alone would melt conventional aluminum structures. They turned to stainless steel honeycomb panels and innovative thermal management systems. The cockpit required special cooling to protect the crew from the intense heat generated by atmospheric friction at hypersonic speeds. Test facilities pushed the boundaries of what was possible. Wind tunnels simulated conditions no aircraft had ever experienced. Propulsion systems underwent thousands of hours of testing. Every component was scrutinized, refined, perfected. The vision was intoxicating. Formations of Valkyries, untouchable at the edge of space, capable of devastating any target on Earth. Soviet leaders would face a terrible calculus. No defense could stop them, so surrender or annihilation were the only options. But thousands of miles away, in the secret design bureaus of the Soviet Union, Intelligence reports about the XB-70 triggered alarm bells at the highest levels of government and military command. Soviet air defense doctrine had always relied on a layered approach: radar detection, surface-to-air missiles, and interceptor aircraft. But the Valkyrie threatened to render this entire system obsolete. At Mach 3 and 70,000 feet, it would appear on radar and disappear beyond the range of Soviet missiles before interceptors could even scramble. The psychological impact cannot be overstated. For Soviet military planners, the Valkyrie represented an existential threat. If the Americans could strike with impunity, the carefully constructed doctrine of mutually assured destruction would collapse. The balance of terror that prevented World War III would tilt decisively in favor of the United States. In March 1961, the Soviet leadership made a critical decision: authorize the development of a specialized high-altitude interceptor capable of matching the Valkyrie's performance. The program was assigned to the Mikoyan Gurevich Design Bureau, already renowned for its MiG fighter series. The specifications were unprecedented. The new interceptor needed maximum speed exceeding Mach 2.8, service ceiling above 80,000 feet, powerful radar and long-range missiles, and rapid climb rate to intercept high-altitude targets before they penetrated Soviet airspace. Chief designer Artem Mikoyan and his engineering team faced extraordinary challenges. Sustained flight at Mach 3 generates tremendous heat. Surface temperatures can exceed 300 degrees Celsius. Conventional aluminum airframes would fail. The Soviets turned to innovative use of steel and titanium alloys, creating an aircraft that could withstand the thermal stresses of extreme high-speed flight. The program received designation YE-155. It would become the MiG-25. But the development timeline was aggressive. The Soviets believed that Valkyrie production would begin imminently, with dozens, perhaps hundreds, entering service throughout the 1960s. Time was not on their side. Soviet engineers approached the problem with characteristic pragmatism. Where American designers prioritized sophistication, Soviet designers emphasized durability and effectiveness. The aircraft didn't need to be elegant. It needed to climb fast, fly fast, and kill American bombers. They selected nickel steel as the primary structural material, not the exotic titanium that Western intelligence would later assume. Steel was heavier but far easier to manufacture and work with. Soviet industry could produce steel components in quantities that titanium fabrication could never match. The weight penalty would be offset by sheer engine power. The Tumansky Design Bureau developed massive R-15 turbojet engines, capable of producing over 24,000 pounds of thrust each. These were brute-force power plants, thirsty for fuel but capable of pushing the heavy airframe to extraordinary speeds. At maximum thrust, the engines glowed cherry red, visible from miles away, a dramatic signature of raw power. Radar systems required similar innovation. The RP-25 Smerch radar was enormous by fighter standards, with a detection range exceeding 100 kilometers. Its vacuum tube technology seemed primitive to Western analysts who would later examine it, but those tubes had advantages: resistance to electromagnetic pulses from nuclear detonations, ease of field repair, and sheer power output that could burn through jamming attempts. Armament centered on the R-40 missile, one of the largest air-to-air missiles ever deployed. Nearly 13 feet long and weighing over 1,000 pounds, the R-40 had the range and warhead to destroy bombers at extreme distances. The MiG-25 could carry 4 of these monsters, 2 radar-guided and 2 infrared-guided, ensuring redundancy against countermeasures. By the early 1960s, 2 engineering marvels were taking shape simultaneously on opposite sides of the Iron Curtain, each designed to counter the other in a deadly aerial chess match that might determine the outcome of World War III. In California, North American aviation test pilots were preparing for the XB-70's first flight. The aircraft was a study in white elegance. Its polished skin reflected the belief that this machine represented American technological supremacy. Engineers conducted systems checks. Propulsion specialists monitored the 6 massive engines. Aerodynamicists reviewed flight profiles. In the Soviet Union, the MiG-25 prototype was emerging from its classified hangar. Built with different priorities, ruggedness over refinement, speed over sophistication, it was a brute force answer to an American threat. Soviet test pilots studied performance data, preparing for an aircraft that would push them to the limits of human endurance. Yet neither nation fully understood what the other was truly building. Intelligence was fragmentary, often exaggerated. Soviet planners assumed Valkyrie production would reach the hundreds. American intelligence knew the Soviets were developing advanced interceptors, but underestimated their capabilities. As 1961 progressed, both programs accelerated. Engineers worked around the clock. Test pilots prepared for aircraft that pushed the boundaries of human endurance. Political leaders watched nervously, knowing that the balance of nuclear deterrence might shift based on these technological gambles. The Cold War had entered a new phase. The Cuban Missile Crisis of October 1962 would bring the world to the brink of nuclear annihilation, demonstrating just how high the stakes had become. In that context, weapons like the Valkyrie and the MiG-25 weren't mere military hardware. They were chess pieces in a game where losing meant the end of civilization. But something was changing in American strategic thinking. Something the Soviets hadn't anticipated. A technological revolution was quietly undermining the entire rationale for high-altitude bombers. The intercontinental ballistic missile was coming of age. In 1960, as the XB-70 Valkyrie program consumed hundreds of millions of dollars, a very different weapons system was proving its worth: the intercontinental ballistic missile. ICBMs offered strategic advantages that even the most advanced bomber could not match. Launch to impact took 30 minutes. No crew was at risk. No refueling was required. And most critically, no defense system existed that could reliably stop them. The US Atlas and Titan missile programs were maturing rapidly. By 1961, America possessed a credible ICBM deterrent. Secretary of Defense Robert McNamara, a man who approached military spending with ruthless cost-benefit analysis, began asking uncomfortable questions. Why spend $700 million per bomber when a missile could deliver the same warhead faster, cheaper, and more reliably? The Air Force fought back. Bomber crews represented tradition, prestige, and strategic flexibility. Missiles were cold, impersonal, automated. Bombers could be recalled mid-mission. Missiles, once launched, could not be stopped. But McNamara was unmoved by sentiment. The numbers told a different story. Moreover, the May 1960 incident involving Francis Gary Powers' U-2 reconnaissance plane had shattered assumptions about high-altitude invulnerability. Powers was flying at 70,000 feet, the same altitude the Valkyrie would operate at, when a Soviet S-75 Dvina surface-to-air missile brought him down. The pilot survived, was captured, and the incident became an international embarrassment for the United States. If the Soviets could hit a relatively slow U-2, what chance did the Valkyrie really have? The bomber's speed was impressive, but surface-to-air missile technology was advancing rapidly. The S-75 that downed Powers had a maximum engagement altitude of 80,000 feet and could intercept targets traveling at Mach 3. Newer systems under development promised even better performance. The strategic landscape was shifting beneath the Valkyrie's wings even before it flew. ICBMs represented the future. Bombers, no matter how advanced, were becoming relics of an earlier era. In 1961, the US government made a decision that would reverberate across continents. The XB-70 Valkyrie bomber program was effectively cancelled. Production was terminated. Instead of the planned fleet, only 2 prototypes would be built, for research purposes only. The XB-70 would never be a weapon. It would be an experiment. The first prototype wouldn't even fly until September 21, 1964, years behind the original schedule, and it would fly into a world where its military purpose had vanished. The reasoning was coldly logical. ICBMs had proven themselves. Surface-to-air missiles were improving rapidly. The cost per unit was unsustainable, and the Soviets, unknown to American planners, were indeed developing an interceptor capable of threatening the Valkyrie. For the American aerospace industry, the cancellation was devastating. Thousands of jobs disappeared. A vision of American air superiority evaporated. Engineers who had dedicated years to the program found their work obsolete. The Valkyrie would become a museum piece before it ever threatened an enemy. Defense contractors protested. Air Force generals argued that strategic bombers still had value. They could be recalled, redirected, used as political signals. Missiles offered no such flexibility. But McNamara's Pentagon was unmoved. The decision was final. The cancellation reflected a broader transformation in nuclear strategy. The doctrine of massive retaliation was giving way to flexible response. Nuclear deterrence no longer required vast bomber fleets capable of obliterating the enemy. Instead, a diversified triad, bombers, ICBMs, and submarine-launched missiles, would ensure second strike capability. The Valkyrie didn't fit this new paradigm. But across the world, in the Soviet Union, the intelligence about the Valkyrie's cancellation arrived too late, or was disbelieved. Even as the XB-70 program crumbled in America, the MiG-25 program accelerated in the Soviet Union. Soviet intelligence was conflicted. Some reports indicated the Valkyrie's production had been curtailed. Others suggested the cancellation was disinformation, that the Americans were actually building a secret fleet of superbombers. The paranoia was understandable. The entire Cold War was built on mistrust and worst-case assumptions. Soviet leaders had seen American deception before. The U-2 flights had been officially denied until Power's capture made denial impossible. What if the Valkyrie cancellation was similar misdirection? Ultimately, Soviet military leadership made a fateful choice: proceed with the MiG-25 regardless. Even if the Valkyrie threat had diminished, the aircraft had value. American reconnaissance planes, especially the SR-71 Blackbird and the high-flying U-2, routinely violated Soviet airspace or probed its borders. An interceptor capable of reaching them would have strategic utility beyond the original anti-Valkyrie mission. Additionally, abandoning the program after years of investment was politically unpalatable. The MiG-25 had become a symbol of Soviet technological prowess, a counter to American arrogance. Cancelling it would be admitting that Soviet intelligence had been wrong, that resources had been wasted, that the West had superior strategic planning. So the program continued. Engineers refined the design. Test pilots pushed prototypes to their limits. Production facilities prepared for manufacturing. The first MiG-25 prototypes took flight in 1964, the same year the XB-70 made its maiden voyage. By the mid-1960s, the MiG-25 was real. It was fast. It was formidable. And the plane it was designed to destroy existed only in a California museum. The irony was complete. The Soviet Union had built one of history's most capable interceptors to fight a phantom. But this ghost would soon find very real targets. In 1970, the MiG-25, codenamed Foxbat by NATO, officially entered Soviet service. Western intelligence was stunned. Satellite reconnaissance and defector reports revealed an aircraft of staggering performance. It could reach speeds exceeding Mach 2.8, over 1,900 miles per hour. Its service ceiling approached 90,000 feet. Its massive Tumansky R-15 engines produced over 24,000 pounds of thrust each. To Western analysts, the Foxbat represented a nightmare scenario. A Soviet interceptor that could threaten high-altitude reconnaissance aircraft and potentially even challenge American air superiority fighters in certain conditions. The aircraft's sheer size was intimidating, over 64 feet long with a wingspan of 45 feet. It was built like a tank, with riveted steel construction that prioritized durability and high-speed performance over maneuverability. The twin vertical stabilizers gave it an aggressive, predatory appearance. The massive air intakes for those powerful engines dominated the forward fuselage, but the true revelation was its mission flexibility. Although designed to intercept the XB-70, the MiG-25 proved adaptable. The reconnaissance variant, designated MiG-25R, was equipped with powerful cameras capable of photographing NATO installations from extreme altitude. These reconnaissance flights became a regular feature of Cold War tensions, with Foxbats appearing over the Middle East, along NATO borders, and anywhere Soviet intelligence required high-altitude imagery. The interceptor variant, MiG-25P, was armed with long-range R-40 air-to-air missiles and equipped with powerful radar. Soviet doctrine called for the Foxbat to operate as part of integrated air defense networks, receiving ground-based radar guidance to intercept high-altitude threats before they could penetrate Soviet airspace. The Soviets deployed Foxbats along the borders of NATO in the Middle East, and anywhere American reconnaissance flights posed a threat. The message was clear: Soviet airspace was no longer vulnerable to high-altitude penetration. The era of impunity was over. Western intelligence scrambled to understand the Foxbat's capabilities. Satellite imagery provided external details but couldn't reveal the aircraft's true performance envelope or technological sophistication. Analysts constructed elaborate theories about advanced Soviet avionics, titanium construction, and revolutionary propulsion systems. The Foxbat became a symbol of Soviet technological advancement, proof that the Eastern Bloc could match Western innovation. The reality would turn out to be more nuanced, but no less impressive. The MiG-25's primary Cold War adversary became the SR-71 Blackbird, the American reconnaissance aircraft that routinely flew along Soviet borders at Mach 3+ and 85,000 feet. This legendary aircraft, developed by Lockheed's Skunk Works under Kelly Johnson's leadership, represented the pinnacle of American aerospace achievement. Built primarily from titanium and capable of sustained hypersonic flight, the SR-71 was virtually untouchable. From the late 1960s through the 1980s, a dangerous game unfolded. SR-71s would approach Soviet airspace on intelligence-gathering missions, their sophisticated sensors photographing military installations and monitoring electronic communications. MiG-25s would scramble to intercept. The Blackbird pilots, monitoring Soviet radar and communications, would adjust course or accelerate beyond the Foxbat's reach. No SR-71 was ever shot down by a MiG-25, but not for lack of trying. Soviet pilots pushed their aircraft to the absolute edge of performance. There were documented cases of MiG-25s exceeding Mach 3 in desperate attempts to close the distance, performance that sometimes resulted in catastrophic engine damage. The R-15 engines were designed for Mach 2.8. Anything beyond that risked compressor stalls, turbine failure, or complete disintegration. The chase became legendary among pilots on both sides. American SR-71 crews respected the Foxbat as the only aircraft capable of threatening them. The standard evasion procedure when Soviet interceptors scrambled was simple: accelerate to Mach 3.2 and climb to maximum altitude. The Blackbird's performance margin was narrow but sufficient. Soviet pilots revered the Blackbird as the ultimate quarry: fast, elusive, untouchable. Intercepting an SR-71 became the highest honor in Soviet air defense. Pilots who achieved radar lock received commendations. Those who closed within missile range, even if they couldn't fire due to restrictive rules of engagement, were celebrated as heroes. The psychological warfare was intense. The SR-71's very existence demonstrated American technological superiority. Its regular reconnaissance missions humiliated Soviet air defenses. Every successful penetration of Soviet radar coverage was a propaganda victory for the West. In the Middle East, particularly during the 1970s Arab-Israeli conflicts, Syrian and Egyptian MiG-25s flew reconnaissance missions over Israeli territory. Israeli F-4 Phantoms and later F-15 Eagles attempted interceptions, but found the Foxbat's speed advantage insurmountable at high altitude. The MiG-25 would simply accelerate away, leaving Israeli interceptors behind. These missions provided valuable intelligence on Israeli military deployments and proved the Foxbat's operational effectiveness beyond the Soviet theater. Arab client states valued the aircraft's unique capabilities, even if the technological sophistication didn't match Soviet domestic versions. The aircraft that was built to kill a bomber that never existed had found its true calling. A high-altitude predator stalking the edges of hostile airspace, untouchable by most defenses, feared by potential enemies. On September 6, 1976, the myth of the MiG-25 shattered and was simultaneously confirmed in one extraordinary event. Soviet pilot Viktor Belenko, a lieutenant in the Soviet Air Defense Forces stationed in the Far East, made a decision that would stun the world. Flying his MiG-25P interceptor during a routine training mission, he suddenly altered course, descended to low altitude to evade radar detection, and flew directly to Japan, landing at Hakodate Airport on the northern island of Hokkaido. The defection was unprecedented. Belenko had delivered an intact, fully functional MiG-25 directly into the hands of American intelligence. Japanese authorities immediately contacted US military officials. Within hours, American and Japanese intelligence officers were examining the aircraft that Western analysts had spent a decade trying to understand. For years, Western intelligence had speculated about the Foxbat's capabilities, often overestimating its sophistication. Now they had an intact example to examine in minute detail. The aircraft was carefully disassembled, every component analyzed, every system tested. The revelations would transform Western understanding of Soviet aerospace engineering. What they discovered was a masterclass in Soviet engineering philosophy, but not in the way they expected. The MiG-25 was built primarily of nickel steel, not titanium as assumed. This made it heavy, over 64,000 pounds empty weight, but incredibly durable and capable of withstanding extreme temperatures. The steel construction also made the aircraft much easier and cheaper to manufacture than titanium alternatives. Its avionics were vacuum tube-based, not solid-state electronics. Western engineers initially scoffed. Vacuum tubes were obsolete technology, abandoned by the West in favor of transistors and integrated circuits. But then they realized the advantages. Vacuum tubes were more resistant to electromagnetic pulses from nuclear detonations, generated less heat in certain applications, and were far easier to repair under field conditions. A skilled technician could replace a failed tube in minutes. Solid-state electronics required specialized facilities and components. The aircraft had limited low-altitude maneuverability. It was optimized purely for high-speed, high-altitude interception, exactly its intended mission. In a low-altitude dogfight against an F-15 or F-16, the MiG-25 would be hopelessly outmatched. But that was irrelevant. It was never designed for that mission. Its radar was enormously powerful, so powerful it could burn through electronic countermeasures, though it lacked the finesse and discrimination of Western systems. The sheer brute force of the radar compensated for its technological crudeness. A target illuminated by the RP-25 Smerch radar couldn't hide behind jamming. The signal was simply too strong. The fuel system was equally pragmatic. The MiG-25 used a special fuel, T6, which was essentially high-octane alcohol. This unconventional choice provided better high-altitude performance and thermal stability than conventional jet fuel. It also meant that ground crews occasionally sampled the fuel for recreational purposes, a problem that required strict security measures. The revelation changed Western understanding fundamentally. The MiG-25 wasn't a superfighter. It was a highly specialized interceptor that excelled at its specific mission. It couldn't dogfight with an F-15. It couldn't perform close air support or ground attack. But above 60,000 feet and at Mach 2.5, it was still one of the most dangerous aircraft in the sky. Belenko's defection provided invaluable intelligence. Western air forces adjusted their tactics accordingly. High-altitude reconnaissance missions became more cautious. Pilots understood that the Foxbat, despite its limitations, remained a formidable threat in its operational envelope. But it also confirmed a deeper truth. The Foxbat, despite its orphaned origins, had become a formidable weapon precisely because it stayed true to its purpose, even when that purpose had changed. Soviet engineers had built an aircraft to do one thing exceptionally well, and that focus created a weapon that remained relevant for decades. The MiG-25's operational history from the 1970s through the 1990s reveals an aircraft that transcended its original purpose through sheer adaptability. Over 1,100 units were produced across multiple variants: interceptors, reconnaissance platforms, trainer versions, and experimental testbeds. The production run spanned more than 15 years, making the Foxbat one of the most successful Soviet military aircraft programs. In Soviet and later Russian service, the MiG-25 served as the primary high-altitude interceptor for 3 decades. It guarded the vast expanse of Soviet airspace, from the Arctic Circle to the borders with China and the Middle East. Reconnaissance variants provided intelligence that NATO could rarely prevent, photographing military installations and monitoring troop movements from altitudes beyond the reach of most interceptors. The aircraft remained in Russian service until 2013, over 40 years after its introduction. Few military aircraft achieve such longevity. The reasons were practical. Nothing else could match its high-altitude performance, and the Russian military budget couldn't afford wholesale replacement with more modern alternatives. Export success proved the Foxbat's international appeal. Algeria, India, Iraq, Libya, and Syria all operated MiG-25s. These export versions were typically downgraded compared to Soviet domestic models, with less capable radar and avionics, but they still offered capabilities unavailable in any other aircraft. In Iraqi hands during the Gulf War, Foxbats flew some of the fastest combat sorties in history. Iraqi pilots, facing overwhelming American air superiority, used their MiG-25s for high-speed reconnaissance missions, evading American F-15 Eagles and F-14 Tomcats through pure speed. One Iraqi MiG-25 was eventually shot down by a US Navy F-A-18 Hornet on January 17, 1991, but only after multiple engagements where the Foxbat simply accelerated away from pursuing aircraft. The Indian Air Force operated MiG-25s from 1981 to 2006, using them primarily for reconnaissance missions over Pakistan. Pakistani F-16s occasionally attempted interceptions, but never successfully engaged the high-flying Foxbats. The psychological impact was significant. Pakistan knew that Indian intelligence could photograph military installations at will, and there was nothing they could do to stop it. Record-breaking performance demonstrated the aircraft's extraordinary capabilities. In 1977, Soviet test pilot Alexander Fedotov flew a modified MiG-25 to an absolute altitude record of 123,523 feet, over 23 miles high, at the very edge of space. This record still stands for air-breathing jet aircraft. No conventional fighter has ever climbed higher. The same year, Soviet test pilots set multiple time-to-altitude records that remain unbroken. The MiG-25 could climb to 30,000 meters, nearly 100,000 feet, in under 4 minutes. This vertical performance was unmatched by any other aircraft in the world. The irony deepened with every passing year. An aircraft built to destroy a cancelled American bomber became one of the most successful Soviet military exports and remained operational decades after its contemporary American aircraft had been retired. The F-14 Tomcat, introduced in the early 1970s, was retired in 2006. The F-15 Eagle, introduced in 1976, remains in service but primarily in ground attack variants. The MiG-25 outlasted them in frontline high-altitude interceptor service. While the MiG-25 flew operational sorties across continents, the XB-70 Valkyrie existed only as two experimental prototypes, beautiful, elegant, and utterly obsolete before they ever reached operational status. The first prototype, designated AV-1, made its maiden flight on September 21, 1964. Test pilot Al White and co-pilot Colonel Joe Cotton lifted the massive bomber into the California sky, beginning a test program that would last nearly 2 years. The flight was flawless. The Valkyrie handled beautifully, its revolutionary design performing exactly as engineers had predicted. Subsequent test flights explored the aircraft's performance envelope. On October 14, 1965, AV-1 achieved Mach 3 for the first time, sustaining supersonic flight for extended periods. The data gathered was invaluable, proving that sustained Mach 3 flight was possible in such a large airframe, validating thermal protection systems, and demonstrating that crews could operate effectively at hypersonic speeds. The second prototype, AV-2, joined the test program in 1965. Together, the two Valkyries flew research missions exploring high-speed aerodynamics, propulsion systems, and the physiological effects of sustained supersonic flight on crews. NASA became involved, using the aircraft as testbeds for supersonic transport research. But tragedy marked the program on June 8, 1966. During a photo flight arranged by General Electric to showcase their engines, an F-104 starfighter escort aircraft, piloted by Joseph Walker, collided with XB-70 AV-2. The F-104's vertical stabilizer struck the Valkyrie's right wing and vertical stabilizers, causing catastrophic damage. Walker was killed instantly. The Valkyrie's co-pilot, Carl Cross, was unable to eject and died when the aircraft crashed. Test pilot Al White managed to eject and survived. The accident devastated the program. Only one flyable Valkyrie remained. Flight testing continued, but the enthusiasm was gone. After 129 total test flights between both prototypes, the remaining XB-70 was retired to the National Museum of the United States Air Force in Dayton, Ohio, where it remains today. A magnificent relic of an alternate history where strategic bombers remained kings of the nuclear triad. The Valkyrie provided valuable research data that influenced future supersonic designs. Its compression lift concept influenced commercial supersonic transport studies. Its thermal management systems informed space shuttle development. Its propulsion integration lessons shaped future bomber designs, including the B-1 Lancer program. But as a weapon, it was stillborn, a threat that justified an entire Soviet weapons program but never materialized as intended. The Valkyrie became a symbol of Cold War excess, a cautionary tale about building weapons for the last war rather than the next one. Visitors to the National Museum of the United States Air Force can walk beneath the Valkyrie's massive wings, marveling at its graceful lines and revolutionary design. Few realize that this aircraft, which never dropped a bomb or threatened an enemy, triggered one of the Cold War's most significant weapons programs thousands of miles away. The parallel stories of the XB-70 and MiG-25 illuminate deeper truths about Cold War military competition and technological development, lessons that remain relevant in an era of renewed great power competition. The fundamental miscalculation was rooted in intelligence failures and worst-case planning. Both superpowers based multi-billion-dollar programs on incomplete intelligence and catastrophic assumptions. The Soviets overestimated American commitment to the Valkyrie, seeing a fleet where only prototypes existed. The Americans underestimated Soviet determination to build a counter, even after the threat disappeared. This pattern repeated throughout the Cold War. The bomber gap of the 1950s, the missile gap of the early 1960s, both proved largely illusory, yet both triggered massive defense expenditures. The military-industrial complex on both sides benefited from this cycle of threat inflation and response. The doctrine shift represented a more fundamental transformation. By the 1960s, strategic nuclear doctrine was fundamentally changing. ICBMs, not bombers, would deliver the majority of warheads in any nuclear exchange. Both the Valkyrie and the MiG-25 were products of transitional thinking, impressive achievements rendered partially obsolete by technological evolution. The submarine-launched ballistic missile, virtually undetectable and invulnerable to first strike attacks, would become the ultimate guarantor of mutually assured destruction. Bombers retained value for flexibility and political signaling, but they were no longer the primary nuclear delivery system. Yet the paradox of deterrence ensured the MiG-25's success despite its target's cancellation. American reconnaissance missions became more cautious after the Foxbat's introduction. Strategic planning had to account for Soviet high-altitude interception capabilities. The SR-71 Blackbird, despite its superior performance, operated with greater caution near Soviet airspace. In this sense, the Foxbat fulfilled a mission its designers never explicitly intended. It didn't need to shoot down American aircraft. Its mere existence forced changes in American behavior. This is deterrence at its most effective, preventing enemy actions through credible capability rather than actual use. The engineering triumph represented by both aircraft cannot be dismissed. The Valkyrie pushed the boundaries of size, speed, and altitude for bombers. Its design innovations influenced aerospace development for decades. The MiG-25 proved that mass production of Mach 3-capable aircraft was possible, using unconventional materials and design philosophies. Soviet engineers demonstrated that technological sophistication could be achieved through different approaches than Western methods. The steel construction, vacuum tube electronics, and brute force radar weren't primitive. They were optimized for Soviet manufacturing capabilities, maintenance infrastructure, and operational requirements. The human element adds another dimension to this story. Pilots who flew these machines, American test pilots in the Valkyrie, Soviet and Allied pilots in the Foxbat, operated at the extreme edge of human capability. Sustained Mach 3 flight subjected crews to intense psychological and physical stress. Cockpit temperatures, despite cooling systems, could be uncomfortably warm. The G-forces during high-speed climbs pushed pilots to their limits. Ejection at hypersonic speeds was frequently fatal. These were not mere vehicles, but extensions of Cold War ideology given form in steel and titanium. Every flight was a statement of national capability, technological prowess, and strategic intent. The broader lesson transcends aviation. Military competition during the Cold War often produced weapons for wars that would never be fought, against threats that never fully materialized, at costs that strained even superpower economies. The Soviet Union's determination to match every American technological advance, real or perceived, contributed to the economic exhaustion that ultimately led to its collapse in 1991. Defense spending consumed an estimated 25 to 40% of Soviet GDP by the late 1980s, an unsustainable burden that diverted resources from consumer goods, infrastructure, and industrial modernization. The MiG-25 program alone cost billions of rubles, money that might have improved Soviet living standards or modernized civilian industries. Multiply this across hundreds of programs designed to counter real or imagined American threats, and the economic impact becomes staggering. Yet these ghost weapons shaped the conflict's outcome in unexpected ways. The credibility of deterrence required visible capability. The MiG-25, parading at airshows and flying along NATO borders, demonstrated Soviet resolve. It validated the billions spent on air defense. It reassured Soviet citizens that their nation could defend them against American aggression. The psychological dimension of this arms race cannot be overstated. Both superpowers needed to believe they were keeping pace, that the balance of terror remained stable, that their sacrifices had purpose. The MiG-25 and Valkyrie, in their different ways, served that psychological need even when their practical military utility was questionable. Today, military planners still grapple with similar challenges. How do you prepare for threats that may never materialize? How do you balance current needs against hypothetical futures? How do you avoid building expensive weapons for the last war when the next war may be fundamentally different? The MiG-25 outlived the Soviet Union itself. The last Russian examples weren't retired until 2013, over 50 years after the program began to counter a plane that flew for less than 5 years. That longevity speaks to the aircraft's fundamental soundness and the Soviets' ability to adapt it to changing missions. One XB-70 Valkyrie rests in a climate-controlled museum in Ohio, a pristine monument to American ambition and the roads not taken. Thousands of visitors each year marvel at its size and graceful lines, unaware that this aircraft triggered one of the Cold War's most significant weapons programs. Scattered across the globe, aging MiG-25s sit in various states of preservation, some in museums, some in storage, a few still capable of flight in the hands of collectors and nations unable to afford more modern alternatives. The story of these two aircraft encapsulates the Cold War's fundamental absurdity and brilliance. Adversaries locked in competition so intense that they built extraordinary machines to fight battles that would never occur, against threats that existed primarily in imagination and intelligence reports. The XB-70 Valkyrie was cancelled because it solved yesterday's problem in tomorrow's war. The MiG-25 Foxbat was built to kill a plane that never existed, and became legendary anyway. In the end, both aircraft served their purpose perfectly, not as weapons, but as symbols. Symbols of technological prowess, strategic commitment, and the willingness to spend fortunes on worst-case scenarios. The generation that lived through the Cold War understood viscerally what younger generations now study as history: that survival sometimes depended on building weapons you hoped never to use, against threats that might never materialize, because the alternative, being unprepared, was unthinkable. Nuclear deterrence required credibility. Credibility required capability. Capability required investment, sometimes in systems whose targets proved ephemeral. The MiG-25 embodied this paradox perfectly. A real weapon chasing a phantom threat, yet effective because it was real. The engineers who designed these aircraft, the pilots who flew them, the strategists who deployed them, all were caught in the Cold War's peculiar logic. Their work was simultaneously vital and possibly futile, necessary and potentially wasteful. They couldn't know which until history rendered its verdict. That verdict is now clear. The Cold War ended not with nuclear annihilation, but with economic exhaustion and ideological collapse. The weapons built to fight World War III ensured it never happened. Mutually assured destruction worked, not because the weapons were used, but precisely because they weren't. The MiG-25 chased ghosts across hostile skies for 40 years. The XB-70 flew into history and legend. Together, they tell the story of an era when paranoia, genius, and determination combined to produce machines that would have been science fiction in any other age.